Hi students. In this lecture, I am going to discuss gravitation. First, let us see list of concepts. First one, Newton's universal law of gravitation. Second, shell theorems. Next, gravitational field strength or intensity. Then variation of G with the height, depth, and latitude. Then calculation of G and calculation of G due to point mass due to thin wire of uniform linear mass density. Next, field due to circular arc at the center of curvature and field due to field at a point on the axis of a ring. Then we discuss potential energy. After that, gravitational potential. Then relation between field strength and potential. And then gravitational pressure. After that, self energy. So we calculate for spherical shell and solid sphere. Then orbital velocity, escape velocity, then Kepler's laws of planetary motion, and finally geostationary satellites. So these are now list of concepts we are going to learn in this chapter. Okay. Now see first heading. Right. It is Newton's universal law of gravitation. So first see what's the statement. The magnitude of gravitational force of attraction between 2 point masses is proportional to product of their masses and inversely proportional to square of the distance between them, and it is along the line joining them. Okay, this is now statement. And coming to note, size of the bodies are small compared to separation between them, then they are taken as point masses. Let us see in detail. So coming to that Newton's universal law of gravitation. So we are taking 2 point masses M1 and M2. See here, first of all, meaning of point masses. Size of the bodies are small compared to separation between them. For example, if you focus gravitational force on Earth by Sun, so when we compare the sizes of Earth and Sun, when compared to separation between them, they are very small. Means we can take them as point masses. Okay. Let us take now here distance between them. It is R. Okay. Then force by M1 on M2 or by M2 on M1. That force of attraction, that gravitational force of attraction is proportional to product of their masses and inversely proportional to square of the distance between them. Okay. Now we are removing here proportionality and keeping here one constant. So F equal to G into M1 M2 by R square. Okay, where G is a constant known as universal gravitational constant. It is known as universal gravitational constant. Now this is a modulus of the force of attraction. But if you want same thing in vector form, see how we take that. So taking the same in vector form. So M1, M2. Let us take its position vector is, it is taken as R1 bar, and position vector of M2. So take it as R2 bar. Now we are focusing force of attraction on M2 by M1. Let us focus force of attraction on second mass due to first mass. That is equal to, so here distance we are taking as, the distance is R, take this as R bar. And here R bar is now position vector of M2 with respect to M1. Okay. Then coming to modulus value, it is same G M1 M2 by R square into minus R cap. So coming to in this one, so what is R cap? From this we can write vector equation that R1 bar plus R bar minus R2 bar. I am writing here R1 bar plus R bar minus R2 bar equal to 0 bar. Okay, see carefully. We are moving along R1 bar, next along R bar, next opposite to R2 bar. That's why it is minus. From this, R bar equal to R2 bar minus R1 bar. So its meaning is position vector of second body with respect to first body. Okay, that is now R bar. Okay, and coming to R cap, it is R bar by modulus of R bar. Okay, and see why we have taken here minus R cap. See, it is now attractive force. So attractive force means force acting on M2 by M1 will be opposite to R bar. So I'm showing here by arrow, that yellow color. Force acting on M2 by M1 is towards M1, means opposite to R bar. That's why I have taken here minus. Okay. So this is modulus value. This is now giving us direction part. It is opposite to R cap. Right. So this is now vector form of the force. Right. Next, coming to here, units of G. From the given expression, we can get unit of G. You can see force, that is Newton, R square, that is meter square, mass into mass, that is kg into kg. So per kg square, that is now unit of G, where G is known as universal gravitational constant. Okay. And see dimension formula coming to Newton. Newton means it is mass into acceleration, right? mlt power minus 2. Check it once. Mass, it is m. Acceleration, meter per second square. So L t power minus 2. Here having meter squared. So I'm taking here L square by kg square. That is m square. Okay. That is now m power minus 1. L and L square. That is L cube. M power minus 1. L cube t power minus 2. So this is now dimension formula for G. Okay. So force proportional to product of masses proportional to 1 by r square. And taking one constant here, that is G, units and dimension formula. Now taking same thing in vector form. Okay, G m1 m2 by r square into minus r cap. The relation is m1 attracts m2. So opposite to r bar. Okay, right. So that is what we have taken here. The statement and size of the bodies are small compared to separation between them. Then taking them as a point masses, right? Let us see problems. 2 point masses 1 kg and 16 kg are kept at a separation 10 meter from each other. Find at what distance a point mass can be placed from 1 kg so that it experiences no gravitational force. Okay. So mass is given 1 and 16, separation 10. At what distance from 1 kg mass? Let's see how we are solving this one. So first write down the given data. One kg, 16 kg, separation equal to 10 meter. So we have to focus at what distance from 1 kg mass we have to place a body of any mass. Okay. Suppose distance equal to x, so that it experiences no gravitational force. Okay. Then see what we can write here. If you place any mass, okay, suppose I'm taking the mass is m. Okay. It can be any value. Now on this, no gravitational force is acting. Its meaning is that this 1 kg attracting this body, so force is left side. This 16 kg also attracting this one, that force is right side. Okay. Now, resultant of these two should be equal to 0. The meaning of no gravitational force. Okay. Then see what we can get. Force on this one by 1 kg. G m1 m2 by r square. It is x square. That is balanced by G m1 m2 by distance equal to 10 minus x square of that. Now see here G and m both are cancelling, remaining 1 by x square, 16 by 10 minus x whole square. So this becomes now 10 minus x is equal to 4x, right? That implies 5x equal to 10. Therefore, x equal to 2. Means at a distance 2 meter, we have to place that body so that it experiences no gravitational force. Okay. And here one more thing, when you are taking the Newton's universal law of gravitation, it is not only for point masses, we can take even for spherical bodies. If you take two spherical bodies, we are taking them as, we are replacing them with the point masses at their center of masses. Then we are taking separation between the centers. That is R. Means when you are taking spherical bodies, we are replacing them with the point masses at their center of masses. Then taking separation between them. That means this is useful for point masses as well as for spherical bodies. Okay, right. Let us see the next problem. Two bodies of same mass m moving in circular path of radius r about their common center of mass due to their mutual gravitational force of attraction. So find their speeds. Given two bodies of same mass in circular path of radius r about their common center of mass due to their mutual gravitational force of attraction. Let us see how we solve it. So taking two masses, given distance equal to, means radius equal to r. Radius r means separation will be equal to 2r, right? Separation equal to, it is 2r. So this is r and this is r. Okay. Masses m and m. Right. See, whenever a body is moving in circular path, so we have to focus who is providing centripetal force. Okay. Suppose we are focusing now this body. This is now following circular path. Okay. So now who is providing centripetal force? So here condition is given that they are moving in circular path due to their mutual gravitational force of attraction. Means a force by this one on this one is providing centripetal force. That means now what I can write here, centripetal force is now gravitational force. So G m1 m2, so m square by r square. Distance is now 2r between them. So G m1 m2 by r square, 2r square. That is now providing centripetal force, which is equal to mass into centripetal acceleration. That is v square by r. R is now radius. Okay. Then see here calculation part. One mass gets cancelled here and one r gets cancelled. Remaining is now v value r v square. So what else left? G. One m is left here. 4 and one r is left. That means speed is square root of gm by 4r. Okay. So like this, we can solve problems basing on Newton's universal law of gravitation. Okay. Okay. Let us see next one more question. Three bodies of same mass m moving in circular path of radius r about their common center of mass due to the gravitational force of attraction. Find their speeds. So this is same as the previous problem. Let us see. The only change is now having three bodies. Three bodies means when they are moving in circular path, if you join them, they form one triangle, right? Right. Let us see now. Join now those three particles that forms one triangle. It is equilateral triangle. Join to here. Then see which forces are providing centripetal force. So masses m, m, and m. You can see now this will be radius. Okay. Let us say we are focusing now this mass. Okay. This right one. So on this number of forces acting, on that, we can see this left one attracting. So force is left side and this also attracting. So force is like this. If you take now resultant of those two, if you take resultant of those two forces, that will be towards the center. That will be towards center. And here both having same magnitude F and F. So here F value G m1 m2 means m square by if side length is L by L square, that is now force. Okay. Now between these two forces, angle is 60. Therefore, now resultant is root 3f. Resultant is root 3f. That root 3f is now providing centripetal force, that is equal to m into v square by r. Okay. Now here see relation between r and L. Okay. Relation is r equal to 2 third of root 3 by 2L, right? See once r value 2 third of root 3 by 2L. Okay. So from this relation between r and L, 2 gets cancelled. R equal to L by root. Okay. Now substitute here. Root 3f is equal to mv square. So in the place of f, take this value. Okay. Let us take that value. It is root 3 gm square by L square, that is equal to mv square by r. In the place of r, I can write it is L by root 3. L by root 3. So root 3 and root 3 gets cancelled and 1 m gets cancelled. The remaining is now, and here 1 L also gets cancelled. So v value v equal to What else left here? It is only Gm by L, right? Root of Gm by L. That is a value in terms of L. If you want in terms of R, then take in the place of L. It is now R root 3. Okay. Then we get the answer. Right.